So far we created movement, collision, room transitions, and an input controller. You could save as the project right now has its own file and use this as a template for any top-down game, whether it be an RPG, a Zelda-like, or a Harvest Moon game. So now we're going to move into the more RPG-specific elements, and we need to start thinking how we're going to hold our character's data, all their information, all their stats, and stuff that make up the character. So we do have a player object, and we could start putting stuff in here. However, we're going to have multiple characters, and while we will be having ally objects to follow the main player on the field, you would run into an issue though when you change the lineup of your party. You could change which character is in the lead, and so storing that information here wouldn't be too useful if what this character represents can change. Also, an RPG is typically divided into two distinct game states, the world and combat. And what object represents our player on the world may not be the same object that represents the player in combat, especially if you do a first-person front-view battle system. So I like it if the player data could exist outside any one object. I'm going to create a new script. I'll create a new group. I call it classes. And I'll create a script called character class. Now these aren't actually object-oriented programming classes, but we are going to start using some object-oriented ideas with the new features that have been brought with the 2.3 update. So I'm going to create a constructor called character. So a struct is basically a lightweight object. It doesn't have any of the built-in variables that your normal objects have. It has no processing overhead. Structs will take up memory, but it's really not that bad. And a constructor acts as a blueprint that we can use for instantiating new instances of these lightweight objects. So we can ask it to look for parameters, name and level perhaps, and then it can have its own instance variables tied to the struct. It can get those from the arguments, and then when you instantiate one of these, you could do something like you would use this new keyword and then call the struct. You can put in whatever name you wanted and a level. And so to create a new one of these with the name and level set to whatever you put in the fields. And you could do this for multiple characters. So this becomes the fundamentals of how we're going to build our party with structs. We'll delete those for now. I mean, obviously you want to call them inside a script. We'll use our game manager object to actually create those. Another thing about constructors is one constructor can inherit from another constructor. And we're likely to share some of the same parameters between an enemy unit and a player unit. So let's create another constructor just called unit. It'll also ask for the parameters, and we can move those up there inside the unit struct. Then to inherit, we can copy this and we'll put a colon and then the unit function call. And now anything inside of here is happening inside of here without us actually needing to retype it inside the character struct. Originally I was thinking we'd create the whole party in this video, but we surely walk before we run. So in this video we're just going to make the struct for the main character. In our game manager, I'm going to create a region called player creation. So you do #region. You can write whatever here you want as a comment. And then you need to do end region. And then anything you write inside of here is collapsible. So I think what I'm actually going to do is one last time we're going to use the global var keyword to create a variable called character. And then I'm going to make that an array. We'll just have one value in there for now. I mean a length of 1 for now. So we can say character 0 equals new character. Then whatever name we want to give the main character. For this project I chose the name Mars. You can name your main character whatever you want. And then their level. And we can add more fields inside of the character class. So we can add experience points, for instance. However, enemies don't need experience points. So we can add that to the parameters exclusive to the character without needing it in the units parameters. And we'll just add it here. So XP will be our experience points, and obviously our character will start with 0. So let's actually make the stats, and one thing you can do is add a struct inside a struct. And I think I would like to have my stats as their own class, so to say. And then we can attach that class to whatever needs to have stats, rather it be a character, an enemy, or even a weapon, perhaps. So let's create a new script called stat class. Say function stats, and for the parameters we're going to need what stats we want to have. So I've worked that out ahead of time what I'm going to use for this project. I wanted to keep things simple and just a small group of stats that didn't deviate too far from something like Pokemon. So obviously we have our resource pools, and then for the main character parameters we have attack for physical damage, defense for reducing physical damage, magic for magic attacks, and for healing. I decided I want to have a magic defense, and so a magic attacks will effectively be defense piercing attacks, kind of like Paper Mario with a 1,000-Year Door. And then speed is for accuracy, evasion, and the order of turns. And feel free to get creative on your own. I mean, you don't have to follow this rigidly. I know a lot of people find it helpful to have one project where you are just literally copying down what's in the tutorial, but then to have another project on the side where you're adding your own spin to it. So whatever is best for you, but if you want to have a magic defense, you know, feel free to add that. If you want to break up some of these, so maybe speed is only turn order and evasion, but you want accuracy to be its own stat, so, you know, add a dexterity stat or whatever you want to do with that. But this is what I'm going to do for the video series. So we'll need HP, MP, attack, defense, magic, and speed. So I put HP and MP into variables called HP max and MP max, so these should be the maximum amount, but then I am going to create separate HP and MP variables that will be the current amount, and we just want to set those to be full when the game begins. So back in our character class, I'm going to add a variable called stats. And this doesn't need to come from a parameter, we can just set it in here. I'm going to initialize it as no one, effectively null. So back in our game manager, let's say character 0 dot stats equal, and we can do the same thing here. We can create a new instance of the stats class and have it stored inside the character struct. So let's fill these out. It doesn't really matter too much what they are. We're not actually balancing them at the moment. So I just had all the main character parameters set to 5. I'm going to have defense set to 0. I think I'm going to make defense an equipment only stat. So the characters will never have any natural defense. They're already getting an endurance bonus through HP as they level up, so it seems redundant to give them 2 to me. Xenoblade Chronicles does it like this. Defense is always 0 if you take off all your armor, and I think that's easier to balance. I think it just makes more sense to me. But again, you don't have to follow this rigidly. You don't have to do everything I do to the letter. But this is how I'm going to do it. And what I would like to do is, if we knew the max value of our stats, if we knew what the base stats for our character is at their highest level. So back in our constant script, let's create a new macro called max level. Oh, I already did that off screen. I set up a stat enumerator. I'll explain why I did that in a bit. But you can set your max level to whatever you want. I just went for the full 99. We're never going to hit that in this project. But it's tradition, so I made a 99. So back in our character class, I'm going to add 2 new parameters to this. I'm going to call one initial stats and the other ending stats. So initial stats is going to represent what our base stats are when we start the game. And ending stats is going to be what our base stats are at level 99, or whatever you put in as the max level. And so why am I only doing these as one variable if we have all those stat variables we made inside the stat class? That's because I'm going to pass these through as arrays. So back in the game manager, let's delete this. And instead we're going to create 2 arrays. The first one for our initial stats, the last one for our ending stats. It doesn't really matter that much what these are right now. That's fine. But it'll be easier to balance the game if we know where we're heading toward. But also, we don't need to actually figure out stats for each level. What I would like to do, and it's something similar to how Pokemon does it, is I'd like it if we just knew base stats and max stats, and then from those we could calculate whatever the stats would be for any level in between. And maybe that's not what you want for your own project, and that's kind of the tricky thing about doing an RPG tutorial, is because when we think of JRPGs, there's a very specific set of mechanics and gameplay we have in mind and that we expect, but then when you take any one of those and break them down, there's tons of different ways to do them that have been done over many different JRPGs. So for me, I'd rather have the game know the initial stats and know the ending stats and just extrapolate the stats for any level in between, but maybe you want stat bonuses to be random and you'd rather have stat growths like Fire Emblem. So if you wanted to do that, I would go back to what we did where we just set the new stats class here like that, what we did, character 0, stats equal, so forth. I would do that. And then inside the player struct, I would have one of these be growth rates, and then I would just make it an array of the growth rates we want for each stat, like that. Back in our stats class, we need to figure out how we're going to actually get those stats from these two variables. We made these two arrays. So we're going to create what's called a method. And you can do these inside objects as well. And you're essentially creating localized functions with the scope of an instance variable. And they're useful for keeping functions grouped together where it logically makes sense for them to be, rather than having the functions in our scripts just for anyone to use. These methods will just be attached to that object. So we basically create it like we do an instance variable. We'll say initialize stats equal, and then function, and then you can declare the function in here. This will turn blue just like an instance variable. However, we're going to be creating multiple character structs. Every time we add a new character with this new keyword, we are creating a new instance of this struct, of this lightweight object. And if we do that, every one of those structs will have their own version of this function. This function will essentially exist multiple times in our game when we don't need it to. We only really need to create this function once. So what we can do is add these... Okay, so what we can do is add this static keyword, and that'll turn yellow. And this will make it so that this variable is only initialized the first time it's called, the first time this function happens. You can actually do this with any variable, and you can do it inside functions or whatever you need. We're not really going to use that too much. It was added in the 2.3 update. You can read up more on that if you want to, but for our purposes, I'm just going to use it to make the methods inside our structs static, so they're only created once. Okay, so in here we can say stats, which has already been declared here, equals new, and then fill it in with our initial stats. You can actually break code up over multiple lines. And you can do it like that and add these. One thing I did that I kind of showed was off screen. I made an enumerator that holds our stats. Like I said in the last video, if you're not familiar with enumerators, each one you're basically adding constants, and the number assigned to the constant is the order that they're added to the field. So HP is 0, MP is 1. So to make our code more readable, we can use those enumerators instead of just the numbers. So I'm going to go through here and do that. Okay. So when this method is called, it will create a new instance of our stat struct and pass in the values from our initial stats array. So then when we create our character, we can call the method right here. However, we can also call the method inside the script like this. And then that will happen once. And you can also call them outside with dot notation. So remember, this character 0 is equal to a character struct, so we can say initialize stats out here, and that will call the method as well. We don't actually need to do that, because we really only need to initialize once, so it's fine just being at the end. And another thing to bear in mind is, because these are variables, even though they're functions, they're being stored into these variables. You can't call them in any order. Like in our scripts, it doesn't matter what order we actually put functions in inside our actual scripts. But these methods that are being stored in arrays, and variables, they do need to be put in the right order. So we can't put initialize stats up here and have it called the same way we could put like character up here and have it called. Like, that's fine because it's in a script, but not when you're using the methods tied to variables. So initialize stats does need to go after you actually create the function. So the next thing we want to do is figure out how we can use the ending stats with the initial stats to get the stats for any level in between. And like I said, we want these methods to be grouped together inside the objects that logically it makes sense for them to work with. And so I like it if anything we're doing with our stats, any adjusting of them, any adding or subtracting of them, could be handled with the stats class inside of it. So we'll create a new method inside of stats called calculate stats. Remember to make it static. And now, just because the struct is inside the character struct doesn't mean it has access to the variables inside of it. So we'll want it to pass in parameters. We'll need to pass in initial stats, ending stats, and the level as parameters. And we can add parameters to these methods just like any other function. And we're just going to keep these as local variables, so we don't need to actually set them as variables. They're fine as is. So I'm going to create a local variable inside of here, another one called diff. I'm not going to define it yet. And then I want to create a for loop inside of here where we'll iterate through every element inside the initial stats array. And the ending stat should be the same length, so that's all good. And so inside of here, we can make diff equal to ending stats I minus initial stats I. So we're looping through every stat that's being held in these arrays. So the first one is HP. Our ending HP was 999. Our initial HP was 20. So right now diff is, 979. And so let's create a new local variable called newStat. And newStat is going to be equal to our initial stat plus the difference multiplied by our level minus the max level. Alright, so this will break up, it finds the difference at 979, and then it'll break it up into evenly separated chunks in accordance to whatever our max level is. So at level 1, that would be, 979 divided by 99, and then it can add whatever that is for every level we have. However, of course, for level 1, we don't want anything added on top of it. We just want the initial stats. And if we do this, it'll make it so when we go from level 2, it'll actually give us the worth of 2 stat bonuses. So you want to do level -1 and max level -1, because we don't actually make any changes at level 1. We just want the initial stats by themselves at level 1. So that'll work, and we can test that out in our game manager. Let's create a draw function, draw GUI, and I'll type draw text, convert it into a string, character 0 dot stats dot HP. No, HP max. And then I'm going to create an event that happens when we press the enter button, enter key, that will level up our character. So we can say character 0 dot level plus plus, and then we want to call that function, that method, so that the stats recalculate. So that's inside the character struct, inside the stat struct. So character 0 dot stats dot then our method, and of course we're going to need to pass in all those parameters. So what might be easier to do is inside our character class, we'll also create a method called calculate stats that can call the stats method for us. So this one doesn't need any parameters. And we can just say stats dot calculate stats, and then we can just pass in what we already have inside of here. And that just makes it easier to be called outside. And also inside our stats struct, we're going to need to actually set the new stats to our stats. And again, we can use our enumerator I made for each stat, and we're going to use that with a switch statement. We're just going to do a switch for which iteration of the loop we're on. And in case stat HP, HP max equals new stat. So we just want to do that for each stat, so I'll do that real quick. Alright, so I actually made a couple mistakes, so I'm sorry, I'll fix those real quick. For when we initialized the stats, I gave them the wrong number of arguments. I forgot to include defense. And then in our stats class, I forgot to actually tell it to be a constructor, so make sure you add that. And then I used the instance level variable from our character class, which this does not have access to, instead of the local one with the underscore. So make sure I'm using the local one. So sorry about that, I was being careless. Alright, let's run it now. Okay, so we have our HP at the top. We begin with 20. And you will notice one issue, but it's not a big deal right now. So we'll level up, and now we have an increase. So the issue is it is a decimal number. I didn't round it, but that's not really a problem. But you can see we're going to increase by the same amount every time. It's about, 979, that 999 minus our initial 20, and then divide it evenly for each level up we'll have until we hit 99, and then it should be exactly 999. So first of all, let's get rid of that decimal by just rounding it. So we'll just round everything that equals new stat. Now, this will lead to some inconsistencies because it was a decimal number, so sometimes your bonus per level will be a point higher than it is normally. If you don't want that, you can use floor instead. However, what if you don't want these stats to be evenly spread out like that anyways? What if you don't want to always get the same number per level up in each stat? Maybe you want to do a system where higher levels give you greater bonuses. When you're 99 and you have 900 health, an extra 9's not too attractive. Back when you only had 20, getting an extra 9 health was pretty great, but later on it becomes less useful. So maybe you want to account for that by having smaller bonuses for early levels and bigger bonuses for later levels. That's what Dragon Quest VIII does, and that's what I like to do. So what we're going to do is add a new local variable called angle. I'm going to set it to 45 to represent a 45-degree angle. And so then when we multiply this with the level, we can multiply it by a tangent. So, it's a logarithmic function where we can get that upward slope. So that's what we're going to use to get the difference in our levels and our bonuses per level. So what this tangent wants is, I'm going to set this back around, but what this tangent wants is the angle. And so we have our 45 degrees angle, but it wants that in radians, not degrees. So this won't actually be a 45-degree angle. But we can convert degrees into radians with a built-in function that GameMaker has called rad2deg, I believe. What's it called? Yeah, rad2deg. And then we can put the 45 in there. That will convert a 45-degree angle into the equivalent in radians. I don't know what that is. Oh, I just realized the mistake I made. We actually want to have the angle modified by our level difference. So that all needs to go inside the tangents argument. And I think I have one too many parentheses. Okay, so that's rounding. That's the tangent. And alright. I did this the wrong order. It should be deg to rad, not rad to deg. So now let's run this. Okay, so there's our HP. We level up 1, going from level 1 to level 2 gets us a bonus of 3 HP. Then 4, 4, 4, 4, 4, and then 5. And then you can see it gets bigger, 6, 6, and then we hit our max. So with that, you'll slowly ramp up the bonuses you're getting per level. Of course, depending on how big the difference is between your ending stats and initial stats, that ramp will be a lot steeper. So there you go. I'm going to set those back to what I had them, 99 for max level, and the player's max HP doesn't matter at the moment. We're not balancing right now. And so I'm going to end there for our introduction to the character struct, how we're going to be holding character data. And we're going to be holding a lot of databases like this, and you may think, That may take up some good chunk of memory. Because like I said, these structs don't have processing overhead, but they do take up memory. But it's really not that bad. So you have about, GameMaker's a 32-bit system. You have about, should be 4 gigabytes, but realistically you only have about 1.5 to 2 gigabytes. I think I've read that's when most people say they have problems, is hitting somewhere around 1.5 to 2 gigabytes. But like, what happens if we create 1,000 of these structs? So just in a repeat statement, let's see. Well, okay, first of all, let me comment that out, and we'll just run the debugger and see how much memory we're using at the moment. It's about 3.34. So now what is it with 1,000 structs? Alright, so it's stabilized about 5 megabytes. So when you think about it, well, that does look like a good sized jump. That's really only 1.5 megabytes for 1,000 structs, and we've got about 2,000 megabytes to work with. So I think this is fine. I wouldn't worry too much about it for using up memory. I think it'll work. So in the next video, we're going to continue talking about the character structs. We're going to add more methods to our stat structs. And then we can start building more characters and have our party set up. So I'll see you guys in the next episode. Thank you for watching.